Hi, today I'm going to use my new model called space frame model to explain the complex theory of relativity by Einstein. According to Einstein, light is the ultimate speed limit in our universe. Nothing can travel faster than the speed of light, and light itself travels at a constant speed, 300,000 kilometers per second. And it does not slow down either, regardless of the source of the light. For example, we have this scenario, a moving spacecraft. So you're traveling at half speed of light, going this direction. We shine a light beam in front of the spacecraft, and we shine a light beam behind the spacecraft. According to the traditional Newtonian physics, this light will travel at 1.5 speed of light, and this one will travel at half the speed of light. Is that right? But as we know, that's not correct. Both these light beams will travel at the constant speed of light. Now, why is that? To understand this, we must understand the basic construct of our universe, the relationship between space and time. Our space is a three-dimensional space, but it is not a static space. If it is static, then we will not be able to move. We're going to be frozen in a static universe. A dynamic one is the one with a lot of frames passing through us. Let's dial it down and look at a simple example. Let's go to a lower dimension. Two-dimensional picture. A two-dimensional picture, everybody has it. We have our family pictures, friends pictures. Pictures are still. Things in the picture do not move. Famous picture, Mona Lisa, is a still picture. She is perpetually frozen in that smile. She cannot smile more, she cannot smile less, because it's the static picture. How can we make things in the picture move? We have to make a motion picture. Motion pictures are actually a series of pictures, series of still pictures passing through our eyes at a fast speed. Currently, it is 24 frames of pictures per second. Picture this, we shoot the action of a tennis player hitting a ground stroke, assuming he finishes that stroke in 1 second. We shoot that film and analyze the film strip. We'll see 24 different still pictures, starting from the tennis player with his racket in his back and moving a little bit forward. At around 12th picture, he's going to hit the ball and follows through and finishes the stroke with racket in his back. We play this film strip in front of a stationary audience. The audience sees a normal motion of the tennis stroke. Now we have a second audience who's not stationary. He runs with the film strip at half the speed of the film strip. Now for him, time slows down on this tennis player. The tennis player no longer can hit the ground stroke in 1 second. It'll take the tennis player 2 seconds to finish the stroke. It's slower. Now if the second audience running at the same speed of the film strip, at this time, he can only see one still picture of this tennis player, and this tennis player will not move, will be perpetually frozen in one position. And that's the same concept with our universe. When we move, we are catching up with the moving space frame. And when we are moving at the speed of light, we are catching up with the motion of the space frame. We will be frozen in a single space frame. Time stops and we will not be able to move. So the concept of time is actually a bunch of space frames moving through us. In one space frame, we're frozen, we're still. We can move a little bit because there's a second frame passing through us, allowing us a little bit of movement. Because there's a large number of space frame continuously moving through us, it allows us continuous movement and we experience time. More space frame pass through us, more change we experience, more time we experience. Fewer space frame passing through us, fewer time we experience. When we are at the speed of light, no frame pass through us, we would not experience any time. We are frozen. And look at this picture over here. The reason why the light traveling both sides at a constant speed, because light itself actually does not move. Light has the ability to stick to the space frame and moves with it. So light actually reflects how fast space frames are moving. Regardless of the source of light, light particle over here just propagates through the space frame. Space frame is moving any direction from anywhere at speed of light. That is why, regardless of the source of movement, the light will always move at constant speed. And that explains also why the gravitational wave travels exactly at the same speed of light. Now we know these two are two completely different subjects, light and gravity. They're not related to each other. Light is electromagnetic wave. Gravity has nothing to do with electricity, has nothing to do with magnetism. But coincidentally, they move at the same speed. Why? Because both of them actually reflect the speed of the space frame. They just attach to the space frame as they move along. So this space frame module can also explain a lot of famous paradoxes in Einstein's theory of relativity. For example, the very famous paradox is the twin paradox. We have twin brother A on Earth, twin brother B on the spaceship, traveling really fast at, say, 0.9 speed of light, going to where? You guessed it, our favorite interstellar destination, Alpha Centauri. Takes like 4.2 years to get there. It takes B probably 2.5 years to get there. So B gets there in 2.5 years, pick up souvenir, coming back, takes another 4.5 years. So 9 years later, B returned to Earth and present to his brother A the souvenir from Alpha Centauri. And then B will be surprised to see that A is much older. So he said, wow, my twin brother, we're about the same age. Why are you much older now than me? A will say, of course, you know theory of relativity. When you're moving really fast, time slows down for you. And after 9 years traveling in space, you aged a little bit, say about a year, and I aged 9 years. That's why I look older than you. So brother B would say, wait a minute, isn't speed all relative? I'm moving fast, but from my perspective, you and Earth are receding away from me really fast. So you're the one should be not aging, and I'm the one should be, aging. How can we explain this paradox? Because they're both moving away from each other. Why A ages more and B ages less? Well, traditional scientists do not have a perfect explanation. They have to somehow employ a third brother, brother C. So no longer twin. It's like a triplets. So they have to have C traveling at a high speed towards Earth, and somehow C and B would meet somewhere close to Alpha Centauri and exchange a look, just make sure that they pass each other. And 9 years later, C comes back to Earth and meet with A, and since C and B and A are identical triplets, so A does not know the difference between B and C, so A would say, oh, okay, now I get it why you're younger than me, because you've been flying all these years and I'm staying here. But that's not really satisfactory, because you still didn't get B back. Now, with my space frame model, actually, we don't need the C to explain this phenomena. It's very easy to explain why A ages and B does not. And B still can see that A ages less. The reason is light travels, or the space frame travels at speed of light from Earth onward. And when B is traveling really fast, fewer space frame from A can reach B. So from B's perspective, he saw a little bit space frame from A reaching him. So he saw like A does not age much. After spending 4.5 years to get to Alpha Centauri, he only saw probably 0.3 years of light frame, space frame, reaching him from Earth. So when he get here, he aged probably about half a year, but his brother on A to him aged only about 0.3 years. So that explains why B saw A ages less. Now things will be different when B turns back, go this direction towards Earth, because now he's going to catch up all the space frame that has not reached B yet. On his way over there, on his way back, he's going to catch all the space frame plus new space frame coming from A continuously. So when he comes back to Earth, all space frame passed already. A aged 9 years, and B in his space capsule aged much less. So here's a nutshell how to explain the paradox A and B. Next paradox, well, next phenomenon we know in the Einstein theory of relativity is length contraction. Length is actually the space between 2 points, as we know. And how can we measure the distance between the two? Well, actually, when we measure how many space frames there are between the two. Say there's a large number, quadrillion space frames between A and B in about a meter. Now, when both A and B moving really, really fast to this direction, there are fewer space frames passing through them. Say if you're at 0.9 speed of light, there's no quadrillion space frame anymore. It shrinks to about, say, 1 trillion space frame between the two. And that's why the distance shrink between A and B. Explains length contraction when you travel at really high speed. With length contraction comes different paradoxes. The famous paradox is it's the tunnel and the train. So we have a train going through a tunnel. The train and tunnel both are about the same length. When the train is traveling really fast, actually the train shrinks. The train is shorter than the tunnel. But from the train perspective, assuming there's captain inside the train, captain over here, he sees things differently. From him, tunnel is moving through, and fast-moving tunnel appears to be shorter. So from captain's perspective, tunnel becomes shorter. And captain says, actually, my head and tail can be both out of a tunnel at the same time. And tunnel says, no, I can prove that I'm longer. I can close my gate, front and back gate at the same time to show that you are shorter than me. If you're longer, then I will not be able to do that. I can only close one at a time, let you out, and close the other one behind you, right? So the tunnel successfully closed both gates for a split second. And he has to open the gate and let the train out, because otherwise you don't want the train hitting your door at the speed of light. No insurance company would like to pay for it. Tunnel did this, but from the captain perspective, these two events did not happen at the same time. Because when the doors are closed, the event has to reach captain's eye at the speed of light. If you're moving in this direction, guess which frame you're going to hit first? Of course, this one. You're moving this way. This space frame has to catch up with you. So the captain is going to see the front gate closed and open first. And when the back gate closed and open event catch up with him, his train is already out. So from his perspective, the front gate closed and open first, allowing him to go out, then the back gate closes and opens when his tail is completely in. And both satisfied, but they just saw things differently. Now, how can we explain the next one? Next one, Captain says, I can prove that I'm longer than you. How I'm going to do this? I'm going to shine a laser beam simultaneously upward to the sky. If I'm shorter than you, then my laser will hit the roof of the tunnel, cannot go up to the sky. Now, if I can successfully shine lights both out to the sky, then prove that I'm longer than you, right? And he did this. And from his perspective, both lasers came out at the same time. But in reality, it was not the case. He sent a command to the laser in front and to the back simultaneously. Fire the laser beam. Signal travels at the speed of light. Now, both laser emitters travel at this direction. So the back laser is gonna hit the signal first. So the back laser will shoot up first when the tail's still outside. And at this point, if the front laser fires, it will hit the tunnel. But the front laser moving at this direction has not received the signal yet. The signal has to catch up with the moving laser emitter. By the time the front laser emitter receives the signal and fire the laser beam up, the front is already out and the back is already in. So from tunnel perspective, this laser beam fired first and later this laser beam fired. But from the captain perspective, both went out at the same time. And that explains how we reconcile this paradox. And that's a nutshell of my space frame model. And hope you enjoy it. Leave comments and I'll answer some questions and do some more videos later on. Thank you so much.